Hello class, this is a video tutorial on rates of change. In this video we'll be looking at how certain real-world phenomena can be modeled using an exponential function. So here we go. So we've been given that the flow rate coming from a well is diminishing due to a drought and modeled as dV on dt equals 3e to the power of negative 0.02 t, and the volume in V megaliters after t months since observing is 0. Okay, here we go. Prove that the flow rate is always positive and its significance to the real world. Well, if we think about this in two parts, that's e to the power of negative 0.02. If we consider this as just e raised t, that's always greater than 0 for all t. Okay, because even if you have negative t, that's, so for example, if you had t is equal to negative 1, that'll be e to the power of negative 1, which is 1 on e, which is still positive. Okay, well, since this is always greater than 0 for all t, then 3 times e to the power of t is greater than 0 for all t as well. And there we go. And what does this mean for the real world? We can say that since, oh no, don't need that. If dV on dt is greater than 0, that means water flows out from the well, flows out from the well. If it's less than 0, that means the water flows back in. Right, in which case, we're only measuring the water going outwards. So let's keep going. Find the volume of the well, I presume, as a function of time. Well, since we have the rate here, so this is the rate of the flow, we can integrate this to find the volume V. Let's do this. It's going to be 3 times the same expression, e to the power of negative 0.02 t, dividing by the coefficient of t. So it's going to be 1 over negative 0.02. Checking the calculator. Oh, already done it here. 1 over 0.02 is 50, so this is negative 50 times 3, which is negative 150 e. And don't forget the plus c. So we always need to solve for that. In order to solve for this, we need to read back into the question. And it says here, the volume after t months since observing is 0. So since observing means the very beginning. So at the very beginning, the amount of volume that has flowed out is 0. So we can say at t is equal to 0, V is equal to 0. So that means this entire expression, let's copy it again. But when t is equal to 0, that's e to the power of 0. This is equal to 0. E to the power of 0 is 1. That's 1 times 150. Solving for c, moving 150 over. That becomes positive 150, so c is equal to 150. So the volume at t months is negative 150 e to the power of negative 0.02 t plus 150. May as well factorize this, giving us 150 equals, make it negative. Negative 150 equals positive e minus 1. That is the function of the volume at time t. How much water will flow from the well in the first 100 days? It's nice and simple. That's when t is equal to 100. So let's take our volume function. So t is equal to 100. That'll be negative 150 e to the power of negative 2. Because substituting 100 here, 100 times 0.02, moving the decimal places twice, negative 2. So this is the exact form. Finding the value here, so it's going to be negative about 129.699. So 129.7, about 130 megaliters it was, megaliters. How much water will eventually flow from the well, and what percentage of water has flowed in the first 150 days? Going back to this concept of eventually, this means what happens when if t approaches infinity, v approaches what value? One of two ways you can do this is just graph the function, or in this case I'm going to be substituting larger and larger values of t. So here's my volume here. Let's simulate what happens when we let t approach infinity. Well, as t approaches infinity, okay, let's change this a bit here. This will become 1 on e to the power of negative 0.02 t minus 1. Well, let's try what happens as t approaches infinity. So e to the power of negative 0.02 of very large numbers, let's say 1,000. This is approaching, well, that's a very small number. So this here approaches 0. Okay, so that's approaching 0 as t becomes very large. So this is essentially going to become 0 take away 1, which becomes 150 megaliters. Well, at 150 megaliters, that's what it will eventually approach. So that's the total amount. Now to find the percentage of the 100 days, we take our calculation and we divide it by the total. So it was this value here. Divide 150. It's going to be as a percentage, so let's multiply by 100. This cancels to be negative, leaving us with negative e to the power of negative 2 minus 1 times 100, that looks about, times 100, 86.5% in the first 100 days. So I hope that gave you an insight into the rate of change using exponential rates. Hope to see you in the next video. Best of luck.